everybody, welcome to your third video. What we're going to be talking about today is we're going to be talking about how to multiply and divide monomials. Our objective for today, which is our goal, is we are going to simplify a real number expression by multiplying and dividing monomials. And the standard we're going to be addressing is 8th grade standard equivalent expression standard number 1. So make sure you copy this down as your header on your first page, and then we'll get going. We're going to define what monomials are, so don't be worried if you don't understand what that word means yet. But let's get started on today's lesson. So, vocab. We have one definition for our vocab today, and it's monomial. We saw that in the objective today, so we need to know what a monomial is. A monomial is a number, a variable, or a product of a number and one or more variables. So what that means is we're going to be multiplying numbers to get it to become one number. It could have variables, it could have numbers. As long as it makes one, that's what a monomial really means. We're creating one number by either having a number, having a variable, or getting the answer of multiplication between a number and a variable. One of the first rules that we're going to go over in this lesson is it's called product of powers. What product of powers is how we multiply two numbers that have exponents as long as they're the same. So, product of powers says to multiply powers with the same base. That means that the numbers that we see are the same. We're going to add their exponents. So here is an example of maybe something you could write down that kind of helps. If I add 2 to the 4th power times 2 to the 3rd power, all I got to do, since these bases are the same, since they have the same base, all we have to do is take these numbers up top, which are the exponents, and add them. So 2 to the 4th power times 2 to the 3rd power equals 2 to the 4 plus 3. Well, that equals 2 to the 7th power. So we add those as long as the base is the same. Now, in algebra, the way it works is this rule pretty much says that if I have a number to a power of m, and I multiply that same number that has another power, but this power is n, all we have to do is say that our answer is going to be the regular number to the n plus m. So we add the two variables together to get our power. So we need to make sure that whenever we're multiplying numbers with the same power, all we do is add them. So what I'm actually going to do before I give you a quotient of powers is we're actually going to practice some examples using this rule. So let's get started on some examples that cover this. For example 1, let's go ahead and try something that should be fairly easy. It says simplify using the laws of exponents. So what we're going to use is we're going to use that law that we kind of wrote down, the product of powers. We're going to use that law to solve this problem. This problem says I have 5 to the 2nd power times 5. Notice that this 5 doesn't have a power. If a number doesn't have a power, it's automatically to the 1st power. Any number by itself is to the 1st power. So what we could do is we could put the power 1 there. Now, if we use the product of power rules, all we have to do is take these two exponents, since the bases are the same and they're multiplying, we take these two exponents and we add them. 5 to the 2nd power times 5 to the 1st power is 5 to the 3rd power. Now the reason why this product of powers works is because if we were to expand this out and we see that everything's multiplying, well, 5 to the 2nd power really looks like 5 times 5. And then we're going to multiply it by 5 to the 1st power, which is just the number 5 all by itself. So, really, how many 5s do I see? Well, I see 3 of those. So this is why we could rewrite it as 5 to the 3rd power. So the product of power rules just says as long as this number is the same and we're multiplying, all we have to do is add these two numbers up top. Those are our exponents. We add those, we get our answer. So this answer is 5 to the 3rd. Let's go ahead and try some more. In example 2, we have something a little bit different than the first. This one has 7 to the 6th power times 7 to the 3rd power. Again, we can follow the same rule. That's our laws of exponents. This is the product of power law. As long as the bases are the same and we're multiplying, all we have to do is add these. So some of you are probably thinking you got it. You're correct. This is 7 to the 9th power. And that's our answer. You don't have to do any further than that. That's okay because it says we can simplify by using laws of exponents. Later on, we're actually going to figure out what these powers are, but let's just keep going. In example 3, we're going to be using variables to solve our problem. In this problem, we have c to the 3rd power times c to the fifth power, our rule still is the same. We're going to simplify by using the laws of exponents. So in this case, I have c to the third power times c to the fifth power. I look, and this still does follow the same rule, even though it's variables. That's a base of c. This is a base of c. So the bases are the same. As long as the bases are the same, we can add the exponents if we're multiplying in between. So c to the third power times c to the fifth power is c to the eighth power. In the fourth example, we're still working with variables. This time we have r to the fourth power times r to the sixth. Again, the bases are the same. Since the bases are the same, go ahead and add the exponents. So r to the fourth power times r to the sixth power is really r to the 10th power. Hopefully you guys are getting this. This is all the product of power rule really is. We add as long as the bases are the same. In example 5, we're working with numbers and variables. So we're going to smash them both together, kind of work the same way. But the only thing is there's going to be something a little bit different in this problem. What I like to say is we have a rule of thumb that we're going to follow. Whenever we're multiplying negative 3 times x squared times 4 times x to the fifth power, everything's multiplying. So that means we can actually apply the commutative property. What the commutative property says is as long as all my numbers are multiplying, we can move things around. One of the best ways that you can do this and always get the answer right is actually you're going to do a rule that I have, and that's put numbers times numbers. So this is a rule that you could follow. Numbers times numbers and bases times bases. So I'm going to show you what I mean by that rule. Look at these two numbers, and we're actually going to make them one number, which is called a monomial. We're going to create the answer of multiplication, create a monomial. What we're going to do is we're going to put numbers together. So negative 3 is going to multiply by 4. Number times number. Then we're going to put the bases together. Well, the bases that I have the same are x squared and x to the fifth power. So I have x to the second power times x to the fifth power. And so what we're going to do is we're going to multiply those. We're going to solve this first. A negative 3 times 4, that's a negative times a positive, which is a negative. 3 times 4 is 12. So when I do the numbers times numbers, I get 12. X to the second power times x to the fifth power, this actually follows our previous examples, the previous 4. What we could do is we could add those because the x's are the same. So 2 plus 5 is x to the seventh power. And what we just did there is we actually created a monomial. Our answer is a negative 12x to the seventh power. We multiplied the numbers times numbers, that's right here. And we multiplied the bases times bases, x squared times x to the fifth power, and that's how we get our answer. Let's see if we can still use this rule and solve the next problem. In example 6, we are still able to use this rule. We can see that we're simplifying by using the laws of exponents. We have negative 7x to the second power times 11x to the fourth power. Go ahead and pause the video. Copy down what we see on the board. If you feel like you can do it, go ahead and try it on your own without playing the video. I'm going to actually solve this, so I'll give you like a quick 1-second pause. Okay, and let's go ahead and solve this. So I'm going to do numbers times numbers first. So I have negative 7 times 11. Those are going to go together. I have x squared, and I'm going to multiply that by x to the fourth power. And again, this is going to be multiplied by that by the time we're done. Negative 7 times 11, that's negative 77. X to the second power times x to the fourth power, again, based on everything we've done, that really is x to the sixth power. And this would be the answer to our problem. We did our numbers first, that's over here, and we did our bases second. And what I mean by bases is they still have to be the same in order to multiply them. So we have the same letter x, we're good to go. Go ahead and pause the video. This is our second rule that we're going to be looking over. So we're done with multiplying powers for right now. Let's go ahead and look at dividing powers. So this is called the quotient of powers. And what we have right here is our rule to how to do it. To divide numbers with the same base, subtract their exponents. So what I mean by that is as long as we have the same base, all we got to do is take the exponents and subtract them. So here you see there's an example. 3 to the power of 7 divided by 3 to the 4th power equals 3 to the 7 minus 4. Well, 7 minus 4 is 3. So this answer really is 3 to the 3rd power. All we had to do was subtract these exponents because we were dividing them and they had the same base. Well, in algebra, here's how it would look. A number to the power of m divided by a number to the power of n. All you have to do is take the m minus the n and you'll get your answer. The only rule is your variable or your base is not allowed to be 0 because 0 to any power should technically be 0. But 0 holds no value, so 0 is a number that we cannot use. So make sure you get this in your notes. This is the second type of rule that we're going to be doing. Let's try some problems. Example 7 says that we're going to simplify using the laws of exponents. What they want us to do in example 7 is they want us to take 4 to the 8th power and divide it by 4 to the 2nd power. So what we need to do is we need to look at what law of exponent are we doing. Well, in this case, we have division happening. So what we're going to do is divide these. Look at the bases though. This is a 4, this is a 4. So all we have to do is subtract the exponents since they have the same bases. 4 to the power of 8 divided by 4 to the 2nd power is equal to 4 to the power of 8 minus 2. Well, 8 minus 2 is equal to 6. Now the reason why this rule works, and I want to show you why this rule works on this first example. After that I won't show you again. But if I wrote 4 to the 8th power out, it would look like this. 1, 2, 3, 4, 5, 6, 7, 8. So this is what 4 to the 8th power looks like. 1, 2, 3, 4, 5, 6, 7, 8. 8 fours, all multiplying. And 4 to the 2nd power looks like this. 4 times 4. Well, in mathematics, we have this rule. If you're taking a number and you divide it by itself, you always get the number 1. So what happens is, if I have 4 divided by 4, that cancels out because it's 1. 4 divided by 4, that cancels out because it's 1. So what we end up with is, after we cancel out the units on top and bottom, we only have 1, 2, 3, 4, 5, 6. Hence how we get 4 to the 6th power. So this rule works because we're able to actually cancel out units to get our number all by itself. Pretty cool, huh? Example 8. In example 8, we're still simplifying using the laws of exponent, still have division happening as we did in the previous example. So this is our second example of how division works. If you feel like you can do this on your own, please by all means go ahead and do it on your own. I'm going to go ahead and solve it. Since we have two numbers dividing and they have the same base, we're going to go ahead and subtract those exponents. 6 to the 12th power divided by 6 to the 2nd power, 12 minus 2, that's 6 to the 10th power. And for right now, we can go ahead and leave it as a number with an exponent. Later on, we will expand that out and we will solve problems like that. But for now, go ahead and leave it like that. That's good to go, and that's how you do those problems. In this example, what we're looking at is we're looking at variables that have exponents. Same rule applies. As long as the base is the same and we're dividing, go ahead and subtract those. So this is n to the 9th power divided by n to the 4th power. Well, 9 minus 4 is 5, so this would be n to the 5th power. I feel like you guys should be getting it. Hopefully you are. If you have any questions, please write down those questions. I'm going to keep going. We're going to do one more, and then I'm going to give you a harder one, and let's see what we can do with it. In this example, we got example 10 here. We're simplifying, still using laws of exponents, still using variables as we did in the previous problem. This is a to the 14th power divided by a to the 8th power. So we're going to go ahead and subtract those exponents, keep the base the same. So a to the 14 divided by a to the 8th, 14 minus 8 is 6. So this would be a to the 6th power. And that's all we got to do for this problem. This right here is good enough for showing me your work as long as you understand how to do subtraction. So I decided to give you a challenging problem to see if we can combine all those rules and see what happens. So in this problem, we're actually combining all the quotient of product rules, looking at many different letters here and numbers. So what we're going to do is go through it slowly. First, do the numbers, kind of like what we did before, numbers times numbers, but in this case, we're going to take numbers divided by numbers. 5 to the third power divided by 5, and that's only one 5. So 5 to the third divided by 5 to the first is really 5 to the second power. So right now, that's where we're at. Do the letters next. Go alphabetically. A to the second power divided by a to the first power. Well, 2 minus 1, well, that's 1. B to the fourth power divided by b to the second power, that's 4 minus 2. That means it gives me b to the second power. C to the seventh power divided by c to the third power, 7 minus 3, that's 4. D to the ninth power divided by d to the fifth power, 9 minus 5, that's also 4. So the final answer I would get using only exponents is 5 to the second power, a to the first power, b to the second power, c to the fourth power, and d to the fourth power. Now, one of the rules we have is if you can actually simplify a number that's kind of by itself, go ahead and do that. So I actually know that 5 to the second power is 25. All of the variables I can't simplify, so I can go ahead and just rewrite those. A, b to the second power, c to the fourth, and d to the fourth. This is the same answer, but this is actually written the correct way when working with exponents. If we can simplify a number down that has an exponent, go ahead and do that. Variables, you can't, so this would be our final answer after we simplify it all down. Let's do one more problem and let's call it a day. You guys are doing awesome. Keep it strong. One more. For our final problem, we got this problem right here. Congratulations for making this far. If you feel like you can do this, go ahead and do it all on your own. But at the end of this one, I actually want you to simplify it down to where you can't simplify it anymore. What that means, get rid of any exponents and tell me the final answer. So, 2 to the fourth power divided by 2 to the third, 4 minus 3, that's 2 to the first power. 5 to the third power divided by 5, well, that's 5 to the first power. 3 minus 1. That's 2. 9 to the second power divided by 9 to the first, because it's all by itself, 2 minus 1, that's 1. So in this problem right now, what I have is I have 2 to the first power times 5 to the second power times 9 to the first power. And a reminder, anything to the first power is itself, so I'm going to go ahead and take these first power off so I can actually multiply my numbers. So, 2 times 5 squared. Now I need to figure out what 5 squared is. Well, 5 squared means 5 times 5. 5 times 5, 25. So what this problem really is this right here. 2 times 25 times 9. Well, 2 times 25, that's 50. So this problem is really 50 times 9. Well, 5 times 9, that equals 45, and since I have a 0, just put a 0 at the end. This answer of 50 times 9 would be 450. Hopefully you like this video, hopefully you understand it. Make sure you're ready for class. If you haven't subscribed, go ahead and click that subscribe button, click that bell notification, and let's get ready for class tomorrow.